Quicksort in Python, explained. Introduction. Quicksort is a highly efficient and widely used sorting algorithm that employs a divide-and-conquer strategy to sort lists or arrays. Developed by Tony Hoare in 1960, it is known for its simplicity and effectiveness in practice. How quicksort works. 1. Choose a pivot. The core of the quicksort algorithm is selecting a pivot element from the array or list. This element will help partition the array into two subarrays. 2. Partitioning. Rearrange the elements in such a way that all elements less than the pivot come before it, and all elements greater than the pivot come after it. After this step, the pivot is in its final position. 3. Recursively apply. Apply the same process to the subarrays formed by dividing the array around the pivot. This is done recursively for each subarray until the base case is reached, which is when the subarray has 1 or 0 elements. 4. Base case. The recursion ends when the subarray has 0 or 1 element. As such, subarrays are already sorted. Key concepts. Pivot selection. The choice of pivot can influence the performance of the algorithm. Common strategies include selecting the first element, the last element, the middle element, or using a random element as the pivot. Partition scheme. Different partitioning schemes can be used. The most common one is the Lomuto partition scheme, which partitions the array around the pivot. Another scheme is the hoare partition scheme, which is more efficient in some cases. Time complexity. On average, quicksort has a time complexity of O(n) log n, where n is the number of elements. However, in the worst-case scenario, it can degrade to O(n)(2), especially if the pivot selection is poor. Space complexity. Quicksort requires O log n, space on average due to the recursion stack. The in-place partitioning ensures minimal additional space usage. Advantages of quicksort, efficient for large datasets. Quicksort is typically faster than other O(n) log n algorithms like merge sort and heap sort due to its in-place sorting and smaller constant factors. In-place sorting. It sorts the elements within the array, meaning it doesn't require additional storage proportional to the input size. Disadvantages of quicksort. Worst-case performance. The worst-case time complexity can be problematic for certain pivot choices. Unstable sort. Quicksort is not a stable sorting algorithm, which means that it may not preserve the relative order of equal elements. Example. Suppose we have an array 3, 6, 8, 10, 1, 2, 1. 1. Choosing a pivot. Let's choose 8 as the pivot. 2. Partitioning. After partitioning, the array might look like 3, 6, 1, 2, 1, 8, 10, with 8 in its correct position. 3. Recursion. Apply the same process to the subarrays 3, 6, 1, 2, 1, and 10. By repeating these steps recursively, the entire array will be sorted. Quicksort is a versatile and efficient sorting algorithm with practical importance in computer science. Understanding its mechanism and characteristics helps in leveraging its strengths and addressing its weaknesses in various applications.